Okay, shall I start?
Yes, ma'am.
Okay, today this class is going to be a continuation from the second practical. Quickly, what was your second practical? Anyone? Topic.
Laboratory apparatus and their users and remarks.
Yes, we have studied about the laboratory apparatus. So a long time ago, I think there are some new students also joined now. So shall we have a quick recap on what we studied? Mainly this class is for showing some videos about the handling of those equipments and glasswares. As there are some new students also joined, we will have a quick recap on what we studied. Okay. So the topic of the session number 2 is study of the laboratory apparatus. And these are the types of laboratory apparatus. This means we can classify the laboratory apparatus as graduated apparatus, general, heating, stirring, filtration, weighing apparatus, and the analytical instruments. Okay, these are the classification of the laboratory apparatus. So can anyone say what are the glasswares will become under this graduated apparatus?
Volumetric Flask,
Volumetric Flask.
Buret,
Pressure cylinder. Pipette.
Conical flask under graduated. Conical flask is under general apparatus. Okay. Under graduated apparatus, we have studied volumetric flask, pipette, Buret. So first we will look into the volumetric flask. And this volumetric flask is made up of glass, which have a long narrow neck and bottom is a swell part. Okay. And this is used for the accurate volume measurement. We can measure a definite volume, which means here at the bottom of the flask. Okay, here at the bottom of the flask, you can observe like 100 milliliter. So that means in this flask, you can fill up to 100 milliliter. Here you can observe a circular round mark. No? Up to this mark you have to fill, and it will be a definite volume that this particular volumetric flask will hold 100 milliliter. Like this, there are several capacities of this flask like 10 milliliter, 20, 50, 100, 250, 500 and up to 1 liter. You can have several capacities of this volumetric flask. So using this volumetric flask, you can measure the accurate volume. Okay. And we can fill the solutions in this volumetric flask using either funnel or using a pipette. And here in this picture, you can see the liquid should be added until this calibration mark. Okay. The liquid should be added until this calibration mark. And the shape of the liquid which forms on the top is known as the meniscus. So the bottom of the meniscus should touch the calibration mark. When you fill, you have to consider the bottom part of the meniscus should touch the calibration mark, and you have to hold your eye at the bottom part of the meniscus. Okay, this is the important point. And when you fill any of the measuring equipments like volumetric flask, pipette or Buret, you have to keep it at the eye level. Eye level means you have to keep your eye at the level of the calibration mark. Then you have to observe the bottom part of the meniscus. Okay. And next we have studied about the pipette. Pipettes are also used for the accurate measurements, and there are two types of pipette: transfer pipette and graduated pipettes. So can anyone differentiate this in the pictures? The first one is transfer or graduated. The first picture.
Transfer.
Okay, the second one.
Graduated.
Okay. Can anyone say the difference between the transfer and the graduated pipette according to the users? Differentiate these two pipettes according to use. Transfer pipette is used for the definite volume measurement. And this graduated pipette, we can take different volumes. This means, like the volumetric flask, you can see this 25 milliliter, 100 milliliter, like this, you can see a definite volume. So here in this first picture, you in this pipette, you can only fill 25 milliliter. But when you consider this graduated pipette, in this 10 milliliter pipette, you can fill any volume within 10 milliliter. You can take 1 milliliter, 2 milliliter, or from 0.1 milliliter to 10 milliliter, you can fill any volume. So this is the difference between the transfer pipette and the graduated pipette. And if you observe the appearance in the transfer pipette, you can find a bulb in the middle. Okay, you can find a bulb in the middle parts. And transfer pipette also consists of several capacities like 150, 100, 25, like that. You can see in transfer pipette in several capacities. And in graduated pipette, you can take different volumes from this graduated pipette. Okay, this is about the volumetric flask handling. Can you hear the sound?
Yes, ma'am.
The unique design of a volumetric flask with its wide body and narrow neck allows for extremely high accuracy when preparing solutions. Volumetric flasks come in standard sizes with 100, 250, 500, and 1000 milliliter being the most common. And the typical accuracy tolerances are plus or minus 0.16 milliliter for a 100 milliliter flask, up transfer solids using a funnel, analytical transfer techniques. Transfer solids using a funnel. Rinse the weighing container, funnel, and sides of the flask with water or solvent. And dissolve or mix the solution with most, but not all of the water. Recall, volumes are not additive, and the density of a solution depends on its concentration. The final volume adjustment, that is, filling to the mark, should be made with as much well-mixed solution in the flask as possible. Use a pipette for best control in adding the final drops of liquid. Something many people forget, with the narrow neck, how do you thoroughly mix the solution to make sure that you have a uniform concentration? The technique I learned was to stopper the flask and invert it 25 times to ensure thorough mixing. And yes, I do count, silently to myself. When
So for the thorough mixing of the solutions, we have to shake it like this.
Important, volumetric flasks are a lifeline.
Okay, can you got it? This is about the handling of the pipette.
Welcome to the video on techniques on the use of a pipette. In this video, we will show you how to deliver 10.00 mils into an Erlenmeyer flask properly using a 10 mil volume.
Conical flask. You know the conical flask, no? You all know about conical flask, no? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. This is about the handling of the transfer pipette.
Metric pipette. First, we inspect the pipette to make sure that the tip is not chipped and the top end of the pipette is smooth and flat. If the top end of the pipette is chipped or not smooth, it is very difficult to pipette. Acclimatize the pipette. Acclimatizing the pipette means to rinse the pipette with the solution to be used.
Before this, you have to rinse the pipette using distilled water or deionized water. After that only, you have to rinse the pipette using the solution which you are going to transfer. Okay. So before this step, you have to rinse the pipette using the deionized water or the distilled water.
In this video, we will be using solution A. When using the pipette, do not pipette the solution directly from the flask in which the solution is stored. This could contaminate the solution. Always choose an appropriate clean and dry beaker and pour a small quantity into a labeled beaker. Here we have two beakers which contain the same volume of solution A. Compare the depth of the solution between the 50 ml beaker and the 250 ml beaker. The solution in the 50 ml beaker has more depth, and it will be easier to pipette the solution out of this beaker. To fill a pipette for acclimatization, use a rubber.
So, when you're taking the solution for rinsing, you can't take it from the directly from the you can't take it directly from the flask which is stored. So you have to take the solution in a beaker. So for the taking of the 30 milliliter, will you use 150 or 500 milliliter beaker or 50 milliliter beaker? The volume is 30 milliliter. You have to take 30 milliliter. So will you use 500 milliliter or 100 milliliter beaker or 50 milliliter beaker?
50 milliliters.
Okay, 50 milliliter beaker. Then only the depth of the solution will be high. Then it will be easy for the uptaking of the solution.
Depth of the solution between the 50 ml beaker and the 250 ml beaker. The solution in the 50 ml beaker has more depth, and it will be easier to pipette the solution out of this beaker. To fill a pipette for acclimatization, use a rubber bulb to.
Okay, you will have this in the coming slides. This is known as the sucker.
Pull up the solution. If you're right-handed, depress the pipette bulb in the palm of your right hand. Hold the pipette in your left hand, but keep your index finger near the top of the pipette. This will make it easier to put your left index finger over the top of the pipette and hold the level of the solution when you remove the pipette
instead
bulb.
of this index finger, you can also use your thumb. Okay, for holding the solution inside the pipette, you can also use your thumb instead of this index finger.
Keep the tip of the pipette below the surface of the liquid to avoid sucking up air and sucking the solution into the pipette bulb. The level of the solution should always rise up the pipette. The solution should not drain back into the beaker. For acclimatization, we draw up a small amount of the solution, about 1/3 to 1/2 of the bulb of the pipette. Remove the bulb and tilt the pipette horizontally to rinse the inner walls of the pipette. Make sure to let the solution slide past the calibration mark near the top of the pipette and rotate the pipette to ensure the solution touches the inner walls of the pipette. Drain the solution completely. After draining all the solution used in the acclimatization, dry the top of the pipette thoroughly and repeat this step 3 times to finish acclimatizing the pipette. Pipette and deliver 10.00 mils of solution A. Fill the pipette with the solution past the calibration mark. Remove the bulb and quickly place the index finger of the left hand over the top of the pipette to hold the level of the solution. Tilt the pipette slightly and wipe away any liquid on the outside surface. Using the same hand, place the pipette between the second and third finger to support the pipette and pick up the beaker to bring the pipette calibration mark to your eye level. Slowly release pressure on the index finger so that the bottom of the meniscus approaches the calibration mark at eye level. At the mark, apply pressure on the index finger to stop the level of the solution such that the bottom of the meniscus is sitting on the calibration mark. Inspect the tip of the pipette to make sure that it doesn't have a hanging drop. If there is a hanging drop at the tip of the pipette, touch the tip of the pipette on the wall of the beaker and recheck to ensure that the position of the meniscus has not changed. Now you're ready to deliver the solution into an Erlenmeyer flask. Bring the pipette to the Erlenmeyer flask and release the pressure on the index finger. Drain the solution into the Erlenmeyer flask with the pipette tip touching the wall of the flask. After draining, wait 10 seconds before removing the pipette. At this point, the calibrated amount of liquid has been transferred. Look closely at the tip of the pipette. A small portion of solution remains in the tip. Do not blow out the pipette. Thank you for watching the video on techniques on the use of a pipette.
So have you understood the handling of pipettes? Have you all understood the handling of pipettes?
Yes, ma'am.
Okay, then let's move into the measuring cylinder. So this is also one of the graduated apparatus, and this is used to measure the approximate volume of a solution. So using measuring cylinder, we can't measure the accurate volume. We can take the volume of the solution, but we can only take the volume of the auxiliary reagents. That means that particular volume is not needed for any calculation works, because only approximate volumes can be measured using the measuring cylinder. So as all the glasswares, it is also a cylindrical glass tube. It is provided with the base stands, and at one end it has a spout for the easy pouring purpose. Okay. And these measuring cylinders can be made either from plastic. The first picture shows the plastic measuring cylinders, and in the second picture you can see the glass measuring cylinders, and you can take different volumes here. And the next one is the Buret. Buret also accurately measures the volume of the solutions, and it is mainly used for the titration purposes. Okay, if you take this Buret, you can observe the zero at the top part of the Buret, and you can observe 50 at the bottom part of the Buret. So this uniform cylindrical tube is starting from 0 at the top, and it will finish with 50 at the bottom part. So here you can see the minimum volume that you can take is 0.1 milliliter, because each 1 milliliter is further divided into 10 portions. So this one portion is mentioned as 0.1 milliliter. So the minimum volume you can take from a Buret is 0.1 milliliter, and the maximum will be 50 milliliter. And here you can observe a stopcock. This is a stopcock which is provided for the facilitation of the control of flow liquid. So you can control the flow of the liquid using this stopcock. And this is the stopcock, and this here it is provided with a stand. Okay. And we will see the preparation of Buret in a video.
Hello and welcome to the UNL Chemistry video series. In this video, we are going to go over the proper techniques for using a Buret. Here is what you're going to need: a Buret stand, a Buret, a funnel, a waste beaker, the liquid going into your Buret, and deionized water with a dropper. The first thing that you always want to do is to clean your Buret to ensure that there are no impurities inside. Take your Buret and mount it in the stand. Place your waste beaker under the tip of the Buret. When the stopcock on the Buret is turned in this direction, it allows liquid to flow through. When the stopcock is in this position, it stops the flow of liquid. For cleaning the Buret, we are going to leave it in the open position. Start cleaning your Buret by taking your deionized water and partially filling the Buret. Let the water run all the way out of the Buret. Repeat this process again. I recommend that you use a dropper to
So if the stopcock is in vertical position, is it means opened or closed? If this stopcock is in vertical position, is it opened or closed?
Open.
Okay, open. So during your cleaning process, you have to keep this in this open position, and while you are filling your liquid, you have to keep it in closed position. Okay.
to help you wash the sides of the Buret. You need to run deionized water through at least 3 times. Now you are going to do the same procedure with the Buret. You need to run deionized water through at least 3 times. Now you are going to do the same procedure with the liquid you're putting into the Buret. Make sure you wash the sides of the Buret with this liquid as well. Again, this needs to be done a minimum of 3 times as well.
Why are you using this dropper for rinsing purpose? Already you have rinsed using a funnel. Then again, why are you using this dropper?
To clean the upper part of the...
Sorry? Can't hear you.
To clean the upper part of the Buret, which is closed when funnel is inside.
Okay, yes, to clean the walls of the Buret, we have to use the dropper. Okay.
After rinsing the Buret, turn the stopcock to stop the flow of the liquid. Now fill the Buret with your liquid. You do not have to be super precise with this. Open the stopcock to let a steady flow of liquid through. There are commonly bubbles trapped in the tip of the Buret. These bubbles can throw off the precision of your measurements, so it is important to get them out. Give the Buret a few light flicks with your finger to remove the bubbles. Once the bubbles are cleared, turn the stopcock. Now fill your Buret to your desired initial volume. I like to fill mine up past the 0 mark, then run the Buret down to my initial mark at 0. Once you have recorded the initial volume, you are ready to use your Buret. Cleaning the Buret is really the complicated part. Measuring liquids with the Buret is the easy part. Place the container you wish to deliver your liquid to underneath the Buret. Open the stopcock and allow the liquid to run. Keep a close eye on the liquid meniscus to make sure you don't go past your mark. Once you get close to your desired volume, turn the stopcock slightly to slow the flow of liquid. Keep turning it to get slower and slower until you have the amount that you want. Once you have your desired volume, make sure to touch the tip of the Buret to the side of the transfer container to transfer the last bit of liquid. If you didn't start at 0, make sure you take your final volume minus your initial volume for the amount transferred. Just remember to use the correct number of significant figures. Since there are graduated lines for every 1/10 of a milliliter, we are going to record to the nearest 1/100th of a milliliter for the correct number of significant figures. Thank you for watching this video. These techniques, when done properly, will help.
Okay, have you got it? The handling of Buret and preparation of Buret before the titration. Have you got it?
Yes, ma'am.
Okay, then let's move into the general apparatus. Can you list out the general apparatus that we have studied?
Conical flask.
Okay.
Beaker.
Glass funnel. Okay.
Wash bottle. Reagent bottle.
Hmm.
Test tube.
Okay, others?
Boiling tube.
Okay.
Moisture can. Crucible.
Okay.
Test tube.
Sucker like this. There are some general apparatus. Okay, thank you. And first we will see the conical flask in general apparatus. These are uncalibrated glass flask. Uncalibrated means here you can see some of the measurements here like 200, 100, 150. But you can't take the accurate volume. You can't measure using the conical flask. This conical flask is only used in the titration purpose. Okay. You can't use this for any measuring purposes. That's why it is mentioned as uncalibrated glass flask, and which is having a wide flat bottom, and it also has a narrow mouth. Okay, this is all about conical flask, and this is used only for the titration purpose. And in case of beakers, these are used to take the solutions for the experiment. Okay, and it's also made up of heat-resistant glass. So for the low temperature heating, you can use beakers. And several capacities of beakers are there, like 100, 150, 500, 1000 to 2000. Like this, several capacities of beakers are there. So when you see this beaker, at the one end of the beaker, you can find a spout. This is used for the easiness of pouring the solutions. So, for the convenience of pouring of the solutions, this spout-like structure is used. Okay, this is all about beakers. And glass funnel, as you all know, it is used to transfer the liquids, and also it is used for the filtration of the solutions. You can hold the filter paper in the mouth of the glass funnel, and you can use it for also for the filtering purpose. Okay, the next one is the wash bottle. Normally, wash bottle is used to take the water which is needed for the experiments. For the experiments, you need distilled water and also normal water. So for the taking of water, you can use this wash bottle. In addition to that, in some reactions, the formation of precipitates may be formed, and it may adhere to the in beaker or glassware. So, for the washing of the precipitate or rinse of the reagent from the particular glassware, you can use this wash bottle. And this wash bottle is commonly made up of polyethylene, and so this is cannot be heated. Okay. And the reagent bottle can be in two colors, brown color and normally colorless amber color bottles. And these are used to store the reagent. And the indicator bottles or dropping bottles are used to store the indicators. And these three tubes, ignition tube, test tube, and boiling tube, in appearance, this will be look like same almost, but the ignition tube is somewhat small, and also it will have a thicker wall. Okay, thicker wall, because this is used for the heating of the solution using flame. So the wall of the ignition tube is somewhat comparatively thicker than the test tube, and it is in smaller in size. Okay, and this test tube can't be heated in flame, and it is used in the experiment purposes. And this is available in several heights or several sizes. And in case of boiling tube, this is resistant to higher temperature. The circumference of this is higher compared to other two tubes, and also the walls of the boiling tube is also somewhat thicker. Okay, and it is also used to do the experiments. And here, can I differentiate the boiling tube, test tube, and the ignition tube? The first one?
Boiling tube. Test tube.
Ignition tube. Okay. And the test tube holder. It is used to hold the test tube during the experiment, especially when heated, or if you add any concentrated reagent or heated reagent into the test tube, you can't hold it by your hand. So you can use this test tube holder to hold the test tube. And the test tube brush, normally this is used for the cleaning of the test tube. And moisture can, in this moisture can, you can use this to keep the samples in oven for the moisture content determination. Okay, you can place the samples inside this moisture can, and then only you have to place it into the oven. And in case of crucible, this is also a heat resistance, and this can be heated directly over the naked flame. And by placing the samples inside this crucible, you can keep it in the muffled furnace for the ignition of the substances. Okay, and it is made up of silica dish or the porcelain dish. And it is used to ignite the substances or the precipitate using flame or in a muffled furnace. So this crucible is used for that purpose. And the desiccators, as I already told, you can place the samples in the crucible and you can place it inside this desiccator. And this desiccator is commonly used in the gravimetric analysis. For example, moisture content determination using an oven drying method. So for the moisture content determination, you have to put the sample inside this moisture can and you have to keep it in oven. So after the removal of moisture, you can take the sample out, but you can't immediately measure the dry weight. You have to keep it for the cooling purpose. So after the removal of all moisture, if you keep it in the outside environment, sometimes the moisture may be regained by the sample from the atmosphere. So you have to place the sample inside this desiccator. If you place the sample inside this desiccator, this will provide a moisture-free and a carbon dioxide-free atmosphere. Okay, so that particular sample which was undergone the removal of moisture will not be affected by moisture, or it will not regain the moisture if you keep this that one in the desiccators. Okay, so this desiccator provide or maintain a dry, which is moisture-free, and carbon dioxide-free atmosphere during the cooling purpose. So this desiccator contains a lower compartment, and also it contains a small plate-like structure. Here, this is the lower compartment. Above this, you can see a plate-like structure with holes, no? So this is a plate-like structure, and above, this is the rim of the lid, and above that, lid. Okay, so in the lower compartment of the desiccator, silica gel or any other desiccants like calcium chloride, activated alumina, or anhydrous calcium sulfate will be placed in the bottom part of this desiccator, mainly for the purpose of absorption of the water vapor. Okay, so at the bottom part of the desiccator, you can observe commonly silica gel is used or any other desiccants which is used for the absorbance of the water vapor. And above that, this upper part is fitted with a porcelain plate. In this porcelain plate, you can place the moisture can or the crucible which contains the sample. So this porcelain plate provides the accommodation of crucible or the moisture can. Okay. And above this, you can observe a glass rim. You can observe a glass rim, which is coated with a Vaseline or a petroleum grease. So this glass rim is coated with the Vaseline or the petroleum grease. So this will provide the airtight condition. For that, if you coat it with the Vaseline or the petroleum grease, carbon dioxide or any other air will not pass inside. So it will provide an airtight condition. Okay, for that purpose, Vaseline is coated. And now you know this desiccator is in the airtight condition. So can you lift the lid upwards immediately? Or can you open the lid immediately upwards? Anyone? This desiccator is now, it is in an airtight condition. So can you open the lid immediately upwards?
Can't, ma'am.
Can't. Because as this is in an airtight condition, if you open it immediately or if you lift the lid immediately upwards, the desiccator may have the chance to be burst or broken. So when you are opening the desiccator, the lid must be moved in a side or in a horizontal direction. Okay, by the horizontal direction, you have to open the lid. You can't lift the lid upwards immediately. Okay, and if you keep a hot substance inside the desiccator, you have to open the desiccator's lid slightly 2 to 3 times to expel the expanded air inside. So if you keep a hot substance, you have to open the lid 2 to 3 times to expel the expanded air inside the desiccator. Okay. Can you hear the sound? Can you hear the sound?
Yes, ma'am.
Hello friends, welcome to the channel Solution. Today in this video we will show you the standard operating procedure of desiccator, means how to use desiccator in proper way. First of all, let's know what is desiccator and how it works. It is one of the type of moisture control system in which we keep any sample or material for two purposes. either to dry the sample if any trace amount of moisture present in it, or it is used when the sample is once dried, then to prevent it from further absorbing moisture, or you can say from reabsorbing moisture by the sample from the surrounding atmosphere. And inside the chamber of desiccator, we place a substance which is a drying agent, and it is called as desiccant. Desiccants are the substance which works by a process called adsorption, and this substance have an ability to attract, or you can say which have a particular affinity for water and have a strong affinity to absorb water, and these desiccants remove water vapor from the desiccator atmosphere and also from the substance placed in it. Now let's know the parts of desiccator. This is a desiccator which is an airtight vessel, and this desiccator is made up of glass. At the top of desiccator there is a lid. Remove the lid and keep it aside. This is the edge of lid which is called as ground glass rim of the desiccator lid, and we have to do greasing here to make the desiccator airtight. Inside the disc you can see here there is a perforated disc. We have to place the sample on this perforated disc. Next, remove the perforated disc from the desiccator and keep it aside. After removing perforated disc, here you can see the section, or you can see chamber of the desiccator, where we have to fill the chamber with the desiccants. Desiccants, as we already told, is a drying agent, means this drying agent adsorbs moisture present in the chamber and also adsorbs moisture present in the sample. Next, we will show you the handling procedure of desiccator. Now, first add desiccants, means drying agent, into the chamber of desiccator. Here we have taken silica gel as a desiccant. You can also use in place of silica gel magnesium sulfate, phosphorus pentoxide, calcium chloride as a desiccant. Now, here we have added silica gel in a desiccator chamber, and this silica gel prevents the sample to reabsorb moisture from the surrounding atmosphere. And now properly spread the silica gel with the help of spatula. After this, lubricate the glass rim of the desiccator lid. Here we will apply thin layer of petroleum jelly, or you can also use paraffin wax or Vaseline, which are available in the market. Or you
So why she is applying the Vaseline? Why she is applying the Vaseline around the rim of the desiccator? Anyone?
Avoid the airtight.
Okay, for the providing airtight condition.
You can use other lubricant to ensure an airtight seal. The main purpose of greasing, or you can say lubricating with petroleum jelly, is to ensure that when we close this desiccator with the lid, then there will be no space between the lid and the chamber, so that to prevent the entry of air from outside the desiccator and chamber become airtight. Now replace the perforated disc inside the desiccator. Now insert hot crucible containing powdered dry drug and put it over the perforated disc of desiccator with the help of tongue. Here we have inserted hot crucible containing dried material into the desiccator to cool it, so that it will not reabsorb moisture during cooling. Now cover the desiccator with the lid. Slide the lid in this way over the desiccator to close it. Do not lift the lid to open the desiccator, as it may lift the desiccator along with the lid and result in breaking of the desiccator because of an airtight seal or desiccator for a longer period of time, as it may result in entry of moisture and saturation of silica gel. So always close the lid of desiccator as soon as possible. So this is all about desiccator. Thank you very much for watching this video.
Okay, have you got it? Have you got it?
Hello friends, welcome to the channel Solution. Today in this video we will show you the standard operating
Okay, can you see my screen?
Yes, ma'am.
So that's all about desiccators. We will move to the next general apparatus, which is the glass rod. So the glass rod is used for the two purposes. Mainly, it is used to stir the solution. Okay, it is used to stir the solutions. So it is used to transfer the liquid from the beaker to the funnel. Okay, for the transferring of the liquids and to stir the solutions. In addition to that, in one end of the glass rod, you can observe a piece of rubber tube. So this rubber tube is provided to rub the beaker if any precipitate is adhering to the sides. So it is used for the rubbing purposes. So these are the uses of this glass rod, and it is available in different sizes. And the next one is scoop. This is used to take the chemicals for weighing and preparing agents. This is somewhat bigger in size than the spatula. This is also made of metal, and it is also used to take the solid chemicals for weighing and the preparing reagents. Okay. And the next one, this is chopper. It is used to close the container, and this will be available in plastic and in cork. And this one will use to close the conical flask or any other bottles. And the third picture. In this third picture, this is also another kind of stopper, which is used to close the glass bottles. So any other reagent bottles, which is used to store the reagents of chemicals. Okay. So these are the two types of choppers. And this one is the sucker or the pipette filler. And this is used to fill the chemicals into the pipette. So you have seen this in the video, which I put to observe the pipette handling. Okay. So this is about the sucker. This is used to fill the liquid chemicals or water into the pipette. And this is the specific gravity bottle. This is used to determine the specific gravity of a liquid. And the weighing board is used for the weighing of samples using the balance. So you can place the this weighing board in the balance, and then you have to do the zero setting. Then you can weigh the sample in this weighing boards. Okay. So this is made up of somewhat plastic kind of material, and this is light in weight, and this is available in different sizes and also in different shapes. So this is used for the weighing of samples using any balance. And the mortaring pestle, as you all know, this is used to grind the solid samples. Okay, that's all about the graduated apparatus and the general apparatus. So anyone have any doubts? Have you got it, or anyone having any doubts? Okay, thank you. This will be continued. Wait for a few minutes. Thank you.
Apparatus. Okay, now I am going to share my slides. Can you hear me? Anybody else?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, this is the continuation of glasswares. Here we are going to see about the laboratory equipments. Here we have studied lot of equipments related to laboratory. But here we are going to see some very important equipments which are used in the commonly used in the laboratory. Okay. Now, first of all, we will see about the oven, which is very important heating apparatus which is available in the laboratories, which is used for the drying purpose as well as to the sterilization of the glasswares. Here in the oven, we can able to dry the residual moisture content, or else we can remove the whole moisture content from the particular sample. After that, we can able to remove the sample from the oven. Here, the drying temperature should be maintained at 105 degrees Celsius for 24 hours. If we are going to use this equipment for the sterilization purpose, here we have to maintain the temperature 160 degrees Celsius for 2 hours, or else we can use 180 degrees Celsius for an hour. Now we will see about the water bath, which is used for the which can able to give the uniform temperature. If we want to heat the particular sample in the water bath, we can maintain the temperature for uniform temperature. If we are going to use the 60 degrees Celsius, we can put the 60 degrees Celsius as the optimum temperature. As well as if we want to heat for 1 hour, we can able to set the temperature, able to set the time as 1 hour. That 1 hour, we can able to get the uniform temperature for these samples. Okay. Now we will see about the muffle furnace. Here we can able to use the food samples, or else we can use the soil sample. If we want to get the ash content of the particular sample, what we have to do, we have to set the time as well as temperature for the muffle furnace. After that, we can place the sample inside the crucible. You have already studied crucible into a glassware as well. If we want to determine the ash content, what we have to do, we have to place the sample in the crucible. After that, you have to place the sample inside the muffle furnace for high temperature. Then only we can able to get the ash content of the particular sample. Here, the temperature should go up to 500 degrees Celsius. So, after the finishing of the particular equipment, we can't quickly take the sample from the muffle furnace. We have to wait for several hours in order to get the room temperature for this particular equipment. Now we will see about the autoclave. In the oven, we have seen we can both use for the drying purpose as well as the sterilization purpose. But the autoclave is mainly used for the sterilization purpose of the glassware as well as to the broth media. For example, if we are going to culture a media, we have to prepare the broth media. The broth media may consist some microorganisms. So in order to eliminate, or we have to kill the microorganisms. For that, we have to place the broth media inside the autoclave. Here, for example, we can, if we want to culture with the agar medium, first of all, we have to sterilize the medium inside the autoclave. The temperature of sterilization is 121 degrees Celsius for 15 minutes and 15 psi pressure. Now we will see about the magnetic stirrer, which is used in order to stir the particular sample. If you want to mix the sample well, we have to use the magnetic stirrer. Nowadays, the magnetic stirrers are consisting the heating purpose also. Heating option also available in the magnetic stirrer. So we can able to stir the sample as well as we can give the heat to the sample as well. and the speed of the steering can be controlled with the options available in the magnetic steerer as well. Now we will see the mechanical shaker. Here in the mechanical shaker, we can place the sample in the conical flask. After that, we can able to adjust the rubbers. After that, that sample will be in a firm position. After that, we can set the time as well, time for the shaking as well as the speed of the mechanical shaker. Then we can able to get the well mixed sample. Now we will see about the vortex mixture. Here for the vortex mixture, we can able to use the screw cap test tube. Inside the test tube, we will put the sample. After that, we will cap using the cap. After that, we can put the sample in the vortex. Here we can able to set the speed as well as time for the steering purpose. Then we can able to get the well mixed solution. Now we will see about the centrifuge. Here what we are going to do, if the sample consisting with the solid particle and the sample consisting both solid as well as liquid, if we want to separate the liquid as well as the solid from the particular sample, we can use the centrifuge apparatus. Here for the good example for the usage of centrifuges, if we are going to analyze the blood sample, if the we know the blood sample consists the blood serum as well as the blood cells. If we want to separate the blood serum as well as the blood cells, we can able to use the centrifuge apparatus. After placing the sample in the tube, we have to place inside the centrifuge. After that, we have to close and we have to set the time as well as the speed, the RPM, rotation per minute. We have to set. After the particular time, we can able to collect the sample from the centrifuge. At the time, you can able to see the separated liquid as well as the solid. The solid will be in the down position of the particular test tube and the liquid part will be in the upper position. Now we will see about the electronic balance, which is used in order to measure the accurate weight of the sample. Here, which may be the food sample or else soil sample, or else we can use, sometimes we will measure the initial weight of some beakers. After some experiment, we can able to measure the final weight of the beaker also. At that time also, we can able to use that particular electronic balance. Now we will see about the Spectra of Photometer, which is very important equipment used in the laboratory. Here, if we want to measure the unknown concentration of the substance, first of all, we have to prepare the non-standard concentrated samples. For example, we can prepare the 10 ppm, 20 ppm, 30 ppm, 40 ppm, and 50 ppm. After that, what we have to do, we have to place the sample in the cuvette. After that, we have to insert the cuvette inside the spectrophotometer. At that time, we can able to get the particular absorbance for the given wavelength. We can set the wavelength in the spectrophotometer machine as well. After that, we will place the sample inside the spectrophotometer. At that time, we can able to we have already known the concentration. After that, we can able to get the absorbance of that particular non-concentrated sample. So with that, we can able to draw a graph using the non-concentration as well as the absorbance. Then we can able to draw a straight line graph from the particular graph. Then we can able to identify the unknown concentrated sample through that created graph. Now we will see about the flame photometer. If we want to determine the concentration of some salts we can able to use the flame photometer. Likewise, in the Spectra of Photometer, here also we have to prepare the non-concentrated sample. Through the standard graph, we can able to get the concentration of the unknown salts which are in the solution. And finally, we will see about the pH meter. Here, as we all know, the pH meter will be used in order to identify the pH of the particular solution. Here, you have already studied the according to pH range, we can able to identify whether the solution is acidic in nature or basic in nature or else in the neutral position. Here, what we have to do, we have to place the electrode inside the solution and we can able to calculate the pH from the pH meter. Here, in the pH meter as well as the EC electric conductivity meter looks like the similar. But if we see the electrode in the pH meter, the electrode is made up of glass. But in the EC meter, the electrode is made up of metal. That's the only difference between the pH meter as well as the EC meter. Okay. If you understand, this is the just recap of your session number 2. If you have any doubt, you can ask. Otherwise, we will go for the videos. Then only you can able to get the further knowledge about these equipments. Anybody else need any clarification? Or else we will go for the video. You can get further knowledge and how to handle each and every equipment in the proper manner. So we will see the video.
Into construction materials test equipment sector, providing equipment and
soil, rock, concrete, aggregate, or similar materials.
First of all, we will see about the how to handle the oven.
It has an effective net volume of 120 liters and an operating temperature range from ambient to 200 Celsius degree. Exterior surface of the oven is covered with powder-coated paint, and the interior part is manufactured from stainless steel material that give the oven a high humidity resistant standard. Additional shelves can be supplied upon request. Inside the walls of the oven, thick fiberglass layers are used for insulation to meet minimum energy requirements. The oven is equipped with a fan that works in forced convection manner in order to create homogeneous temperature distribution inside the drying chamber. Fan sucks the air from the middle part and forces from upper and lower holes.
Here in the oven, the convectional heat will be spread inside the oven. Here, before placing the sample inside the oven, we have to place the trays inside the oven. After that, we have to set the optimum temperature which we want to use, and we can also use the time as well as the temperature which we want to use in the oven.
On top of the oven, there are 3 hole openings. The humid air of the drying chamber is exhausted, and the dry air is introduced to the chamber from these holes. The amount of discharged humid air can be adjusted by setting the opening levels of these holes to achieve an effective drying operation. The circulation fan cools itself by aspirating the fresh air from the holes at the rear side of the oven. Therefore, some clearance should always be left between the back of the oven and the wall. In order to operate UTD1300, open the device, put the sample on the steel shelf. And turn on the power switch. On the screen of the control unit, the oven temperature is displayed on the top, while the set temperature is displayed at the bottom. In order to change set temperature, use the up and down arrow buttons. After reaching the target temperature value, release button, and it will be saved in seconds. To protect the device from unstable electricity currents or overloads, a glass fuse is utilized, and it is located at the left side of the oven. Open the lid by using a screwdriver, change the fuse, place the lid, and fuse back again.
Up to now, you have seen about the how to operate the oven. Now we will see about the water bath. In the water bath, before we are going to place the sample inside the water bath, we have to add the water inside the water bath up to optimum level. Otherwise, the alarm sound will be audible. The alarm will be says that the H2O level is not enough. Like that, the error sound will be audible. After that, we have to check the optimum level, whether the water is in the optimum level or not. We have to fill up to optimum level, and we have to wait up to particular temperature. After that, we have to place the sample inside the water bath. Okay, now we will move to the next apparatus, muffle furnace. sample from the muffle furnace, we have to use the beaker tongue to remove the crucible from the muffle furnace, because which will be in a high temperature. So we can't directly take from our own hand. So we have to use the beaker tongue in order to remove the crucible with sample from the muffle furnace.
To use a scalpel that...
Now we are going to see how to handle the autoclave, which is used for the sterilization of the glasswares as well as the growth media.
It has bacteria growing on it? Of course not. Surgical instruments must be sterilized. That means no living organisms are present. There are lots of products that need to be sterilized. Pharmaceuticals, equipment, solutions, medical waste, even tattoo needles. If bacteria, fungi, or viruses are present, the result could be deadly. So how do we sterilize materials in the lab? We use a device called an autoclave. Basically, an autoclave is a powerful pressure cooker that uses heat, steam, and pressure to destroy microorganisms. First, we'll sterilize a solution using the slow exhaust cycle, and second, we'll sterilize some empty bottles using fast exhaust. We need to sterilize this flask containing an agar bacterial media. Cover the top with foil and place a piece of autoclave tape over the foil. Autoclave tape looks like regular masking tape. The difference is that it has a special ink that causes black diagonal lines to appear when exposed to high temperature. Turn on the power and make sure the drain valve is closed. Add deionized water to the level indicator line. Place the flask of culture media into the basket. Insert the basket, close the lid, and turn the handle to create an airtight seal. Use the control panel to set the mode to sterilize, the temperature to 121 degrees Celsius, and the pressure to 15 psi. The slow exhaust mode prevents the liquid from boiling over and out of the flask. Run the autoclave for at least 15 minutes. While it's running, enter the date and time and the operation details in the log and initial. Once the cycle ends and the pressure gauge reads 0 psi, slowly open the door wearing heat-resistant gloves. The black lines are visible on the autoclave tape, indicating that the proper temperature was reached. Once the culture media has cooled to about 45 degrees Celsius, it's ready to be poured into Petri dishes. Now let's run a second autoclave cycle, this time using the fast exhaust to sterilize some empty bottles. Tighten the cap, but then loosen it about halfway. Place the autoclave tape over the lid and put the bottles into the basket. Set the autoclave to 121 degrees Celsius, 15 psi, and a 20-minute runtime. Select the fast exhaust mode. Complete and initial the log. Once the cycle ends and the pressure gauge reads 0 psi, slowly open the door and remove the basket. The black lines are visible on the tape, indicating that the proper temperature was reached. The autoclave is now ready for another run. Remember, slow exhaust is for liquids and medical waste. Fast exhaust is for empty glassware and instruments. Now you're ready to go to the lab and use an autoclave.
Up to now, you have seen how to handle the autoclave. Now we will see how to use the magnetic stirrer. Here we can able to set the speed of the magnetic stirrer, as well as if you want to use the heat as well, we can able to set the heat option as well.
This is Joe. Say hi, Joe. Hi. He's a designer, a great one.
Now we will see about how to use the mechanical shaker. As well as the RPM settings in order to well mixing of the solution.
When we say your balance your way, with 100% configurability and thousands of configuration.
Now to mechanical shaker, how it works. Now we will see how the vortex mixture works. Here we have to use the screw cap test tube. Okay.
When you think about your lab, a mixer is one of the objects you use most in your daily routine. Our Vortex mixers have been designed to be very powerful, very stable, and really easy to use. The patented IR sensor provides a completely different experience to that which you have ever had in the past. The TX4...
Here you could able to see how two solutions are mixed well. Okay.
Guides the user with an extremely bright and easy to read display, showing all the most important parameters and the timer. Lower speed settings allow for gentle mixing, whilst control ramping and high speeds ensure vigorous vortex mixing while remaining stable. Quiet operation makes a significant contribution that directly benefits the user, just like the possibility to use different attachments and platforms for the most diverse applications. Velp Scientifica TX4, a vortex of modernity in your lab.
Hi, I'm Marie.
Now we will see how centrifuge work. How from the particular solution, how the liquid as well as the solid part gets separated. Here, for that purpose, we are going to use the centrifuge apparatus.
I'm a graduate student at Harvard University working in Victoria D'Souza's lab, and today in this video, I'm going to be teaching you about the basics of centrifugation used in biology. The basic principles behind centrifugation involve rotation around a single axis. This creates a rotational force that goes in the direction of a circle. So if you imagine my center of my axis is in my hand here, and I have a circle of rotation, I have a rotational motion that's following the direction of the circle. The accelerated force that's created is shooting outwards, perpendicular from the circle from all directions. This allows all of my sample to eventually gather at the very end of my tether, at the very end of the tube.
So here, due to centrifugal force, here the solid sample will be get into the bottom part of the tube. Likewise, the liquid part will be gathered in the upper portion of the particular test tube.
Centrifugation in biology is used for several different purposes. We like to use it to gather all of our samples together. We also like to use it to separate out particles within a single sample. Today we're going to be using a basic tabletop centrifuge. When I approach a centrifuge, I can open it using this open button over here, which exposes the main body where the centrifugation happens. Usually there's a little screw top lid that sits on top of this, which when you pull open, you'll find the areas where all your samples are actually located. The other part of the centrifuge to pay attention to is the menu body here, where all your different settings are controlled for your centrifuge. The first one is time. You can see I have it set to 30 seconds right now. I can also increase or decrease the time as I see fit. I'm going to leave it on 30 seconds. The other setting to control is the speed. The speed, the important thing to take note of, is the unit that you can see right here, which is in RPM right now. There's two different speed units, and the two units are very different from each other, so this can drastically affect your experiment if you're using the wrong one. You have RPM and RCF. RPM is measured in terms of revolutions per minute. So if you imagine I start here on the circle, I go all the way around 360 degrees, that would be one revolution around my circle. So RPM is really just measuring how many revolutions around the circle my centrifuge is making every minute. But you can imagine to get the same amount of force, a different centrifuge with a different radius or a different size might have a different revolution per minute. which is why we use this other unit, which is called RCF, in order to give you a more uniform unit between which you can measure different centrifuges. RCF is relative centrifugal force and measures everything relative to G, the gravitational force, which is also why in your protocol you might sometimes see this written as times G. The first application of centrifugation in biology that I'm going to show you is the collection of samples at the bottom of your tube. You can see here I have my sample of blue liquid. If I shake up my tube, my sample will be dispersed throughout the tube. When I'm working with such a small volume, these tiny droplets will actually take up a more significant ratio of my total amount of sample and can actually make a big difference in my experiment. And so I'm going to want to collect all my sample at the bottom of the tube. When you're loading your centrifuge up, the important thing to pay attention to is that you load your samples in a balanced way around the circle. This means making sure that the weight is evenly distributed throughout your centrifuge. As I've loaded this right now with just one single tube, it isn't distributed. All my weight is concentrated on one end of the centrifuge. For a little tabletop centrifuge like this, it may not be as important, but as you do more centrifugation at higher speeds, the tiny differences in volume will make more and more of a difference. If I only have one single tube here, what I can do instead is make a balance to balance it out, and I can do this with something as simple as water, where I just take a volume of the approximate same volume, stick it into another clean tube, and pop it right opposite of my original sample in order to balance my centrifuge out. And then it's important to tighten on the lid so that your sample won't leak around the centrifuge if anything breaks. Close it, and then we can start our run. When my centrifuge finishes running, you'll see that first I have my blank, which is still there, and then my sample has all collected at the bottom of the tube. There's no more blue on any of the surrounding areas of the tube, and this is exactly what I'm looking for. The second application, when my spin is done, I can unscrew my lid again, and I can see here, and you might be able to see the contrast better against the black gloves, where I created a pellet of the cells, of the bacterial cells at the bottom, with the liquid supernatant on the top. I don't want the supernatant for the purposes of my experiment, so what I can do is take a pipette tip and be very careful about removing the supernatant just from the top without disturbing the pellet at the bottom. I'll put the supernatant into my waste tube over here. You want to make sure you don't put your tip all the way to the bottom where it's going to touch the bacterial pellet, but just let it skim gently at the top while you slowly remove all of the liquid. Just like that. This will leave you with a nice, clean pellet at the very bottom, free of any supernatant. This concludes the video on basic centrifugation.
Up to now, you have seen how to use the centrifuge apparatus. Here, after the centrifugation, you can able to get the solid particles from the liquid particle. Okay, after that, now we will see how to use the analytical balance. You have already seen this analytical balance for your previous practicals as well. Here, in order to measure the accurate volume of the sample, we are going to use the analytical electronic balance.
One of the most commonly used pieces of equipment in biotech laboratories is called an analytical balance. We can use it to take very precise measurements, 4 places to the right of the decimal point. Keep in mind that a small paperclip weighs about 1 gram. In other words, the analytical balance isn't designed for weighing heavy items. For example, this balance has a maximum weight of 310 grams. That's about the same weight as a can of tomato soup. Weighing anything larger than that will cause damage. The first first consideration is selecting the workspace.
Here in the balance, you can able to see for each and every electronic balance, which is having the minimum as well as the maximum range of the weight. Here, for example, if the balance is consisting the maximum of 300 grams, then we can't use more than 300 grams. If we use more than that, which will cause the damage to the analytical balance.
The balance needs to be placed on a steady surface such as a marble counter or a lab workbench in order to minimize vibrations. The balance shouldn't be used near doorways or air vents because it's sensitive enough to be affected by air currents. Check to see if the balance is level. Adjust the feet until the air bubble is inside the black ring. If the balance has been unplugged or turned off, you need to let it warm up and reach the required operating temperature. Let's try an example. We want to measure out 1.5 grams of sodium bicarbonate. Typically, we use weighing paper for measuring anything less than 5 grams. Fold the opposite corners of the weighing paper together and make a crease. Then do the same for the other corners. Place the paper on the balance pan. Close the side doors and press the tare button to zero out the paper. Use a lab scoop to slowly add the sodium bicarbonate to the paper. Close the glass doors and wait for the balance to lock in its reading. Continue adding sodium bicarbonate until you reach 1.5 grams. Close the doors to read the actual weight. 1.5026 grams. And always document your work in your lab notebook. Let's do another example. This time, we'll weigh something a little heavier, so we'll use a weigh boat instead of paper. Let's measure out 12.19 grams of powdered tris buffer. Place the weigh boat on the balance pan. Close the side doors and press the tare key. We're aiming for 12.19 grams, so the measurement should be within plus or minus 0.02 grams. Always document your work in your lab notebook. Cleaning the balance is an important step, especially at the end of the day. Put it into standby mode or unplug it. Remove the weigh pan and components by lifting straight up.
Each time after the measurement, you have to note the weight of the sample into your notebook. Likewise, if you want to change the mode, for example, if you want to measure, you can change the mode to milligram, or else you can change the mode to gram. And after each juice, you have to clean the weighing balance properly.
Use a very soft bristle paintbrush to sweep off any powder remaining inside the weigh chamber and in the grooves for the glass doors. Once it's clean, replace the drip ring and the weigh pan. Ready to head into the lab and practice using an analytical balance hands-on. To find
Up to now, you have seen how to use the electronic balance. Now we will see how to operate the Spectra of Photometer.
Here we have the 3 cuvettes, and this is just a sample. You can see the relative color intensity from cuvette 1 to 3. And what's important about this is that I want you to see the difference in the sides of the cuvette, the plastic cuvette. You can see one part, the part that is facing towards the front is actually, and the front and the back is actually matte surface, that means it's rather a little bit uneven, whereas the surface at the side of the cuvette is clear. So that will come in important when we put the cuvettes in. Okay, this is what we see inside the spectrophotometer, and this is where we put the cuvettes. These will be the slots in which we put the cuvettes, and you can see this little hole at the side is where the light would come out from of that particular wavelength that you set the spectrophotometer at. The light would come out and then pass through the cuvette, and that's why when we put in the cuvettes, we have to do them with the matte surface facing forward and the clear surface facing sideways, so that later on when the light comes out, it can pass through the clear surface with no problem and get captured on the other side of the spectrum.
When you place the cuvette, you should ensure the clear part is in the way of the lens, the light lens. Here you could able to see the lens. At that direction, you have to place the clear part of the cuvette.
So how we put it in, okay, this position is actually cell 1. Closest to you would be cell 1, and then 2, and then 3. So I'm putting in cuvettes 2 and 3 in that order. Once you have placed the cuvettes inside the spectrophotometer, close the lid and make sure that the display is to the main measurement page, which should look something like that with the wavelength that you're using. Okay? And all you need to do is to press the start button, which is at the bottom right hand corner. It's green. Okay, so we press it now. Once you have done that, the spectrophotometer will measure for you the absorbance at that particular wavelength. You can see the wavelength up here. And these are the results. Actually, just now we only put 3 cuvettes in, and sometimes when you do this after another group has tried it out, you will see something like this. Now what does this mean is that the first group had these 3 results. These are not yours, but the ones that are the later set would be, in this case, sample 2, and these are...
After the placement of sample, you have to set the proper wavelength for that particular sample. Then you have to press the start button. Then you can able to get the absorbance for the each and every sample which was placed inside the spectrophotometer.
Cuvettes 1, 2, 3 that we placed in order just now. And with 1 being closest to us and 2 being further away, 3 being the furthest away from where we were. So these are the readings that we should take note of, the absorbance, and you can see that according to what we saw visually, the absorbance increases with color intensity. The darker the color is, the more wavelength, the more light it absorbs at that particular wavelength.
Now we will see how to operate the flame photometer in order to identify the salt concentration.
This is a flame photometer. It's an instrument that can be used for reading the emission of a solution. So before we can use the flame photometer, there is a need for us to do a calibration. To start with the calibration, we will be needing a standard which is having the highest concentration. So from the standards that I prepared, which are in different concentration. I will be picking my standard, which is having the highest concentration. And from here, I have to put the highest standard in a cup, which is now prepared in this cup. And the next thing I will do is transfer the tube, because in this small tube, that is where our sample will be passing through. So it is where the samples will be introduced to the flame photometer. So now that I have my highest concentration, I have to set here 10 ppm by using this fine knob. By the way, we will be analyzing sodium, so we have to make sure that our filter here is set in sodium. So now we will adjust this to 10 ppm with this fine knob. We have to adjust the 10 ppm. We have to adjust this by using this knob. So after adjusting 10 ppm with this knob, next is place the cup with water. So our blank for this is water. For the blank, we have to achieve a 0 reading. So in order for us to adjust this, we can adjust it with the blank knob. So there are only two adjustments.
Here for the blank, we are using the distilled water. Here we have to place that small tube inside the distilled water. After that, you have to get the 0 setting in the flame photometer.
Adjustments we need to do. We have to adjust the highest concentration, and we have to adjust the blank. So those are the only two things required to do the calibration. After that, we can now proceed in reading our next standard. So if we have 5 standards, we will just replace this 5 times. So once you put the next solution to be read, automatically it will be displayed on the screen, whatever reading it is. And take note that we will only do the calibration only from the start. So there is no need now to touch anything from the flame photometer. So just
After the blank, we can able to change the concentrated samples, and up to constant reading, we have to place that sample inside that small tube. Then after that, you can change the each and every concentrated samples.
proceed. No matter how many solutions we will be having, all we need to do is just keep replacing.
Now we will see about the pH meter. Can anybody tell what is the optimum range of acidic, basic as well as the neutral pH? You have studied in your previous practicals. Can anybody tell what is the optimum pH for the acidic solution, neutral solution, as well as the basic solution? Can anybody tell? we will see the video. After that, you can memorize or recall the pH range.
The arm, and the electrode. Include the meter, the arm, and the electrode. The arm allows the electrode to be easily moved up and down into a beaker with a sample to be tested. Prior to use, a pH meter should be calibrated using color-coded buffers of fixed pH. pH 4, 7, and 10 are standard. The first step in using a pH meter is to remove the protective cap from the electrode. The electrodes of the pH meter need to be stored properly, capped, and immersed in a storage solution to prevent them from drying out. Next, the electrode must be rinsed using distilled water. Various pH meters will have different procedures for calibration. To calibrate your pH meter, you will need to review the owner's manual for the proper procedure. Begin the process of calibration using the standard with a pH of 7. Once the standard has been calibrated, you will need to remove the sample and rinse the electrode with distilled water.
After calculating each pH of the solution, you have to clean with the distilled water.
Repeat the process again, this time using the standard with a pH of 4. Once the standard has been calibrated, you will need to remove the sample and again rinse the electrode with distilled water. You will then calibrate the final standard with a pH of 10. When the pH 10 standard has been calibrated, rinse off the electrode with distilled water. pH meters must be calibrated each time to ensure the accuracy of measurements. Using the 3 different pH standards for calibration provides for a wide range of accuracy. You are now ready to measure the pH of an unknown solution. Place the unknown solution beneath the electrode and slowly lower the arm so that the electrode is fully submerged in the solution. This sample has a pH of 5.57 at a temperature of 23.9 degrees Celsius. Once the reading is complete, remove your sample. Once again, rinse the electrode with distilled water. If this is your final sample, replace the protective electrode cap for storage.
This is the final video for this class. If you had any doubt, you can ask now. Anybody else? Have you understand anything else? How to handle each and every equipment? Anybody else tell? Yes or no?
Yes, ma'am.
Okay. Do we have any doubts? Okay. In the absence of doubts, we will wind up our class. Thank you very much.
Thank you, ma'am. Thank you. Thank you, ma'am. Thank you, ma'am.